welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and today we'll be doing Unit 11, Lesson 3, Solving Systems by Elimination. So at this point in time in this unit, we've seen, what a system is and what it means for a set of values to be a solution to that system. We've also seen how we can solve a system of two linear equations by graphing the two lines and finding their intersection point, or by substituting one equation into the other equation in order to eliminate one of the two variables. Now today, we're going to be looking at a very, very peculiar method for solving systems that only works, sometimes. I mean, you could make it work all the time, but you'd really have to kind of manipulate stuff, and it's called the method of elimination. So let's get into what that method is. All right, now, reviewing this, we've now seen how to solve systems using a graph and by substitution. Our final method, at least in this course, works well when all the variables are on the same side of the equation. So if you recall from our last lesson, substitution worked particularly well when one equation or both equations had a variable isolated all by itself. So there was like a y equals or an x equals in one of the equations. The method of elimination is going to work well when both variables in both equations are on the same side of the equal sign. So let's start by taking a look at exercise number 1. Two numbers, x and y, have the property that their sum is 21 and their positive difference is 9. Let x be the larger number. Letter A, model this situation with a system of equations. All right, well, we've done one like this before. I'd like you to try to set up a system of equations that gets you both the fact that the sum is 21 and the positive difference is 9. Keep in mind, x is the larger number. Pause the video now and see if you can write down this system of equations. Well, the fact that their sum is 21 is very easy, right? For that, all I need to do is write down x plus y is equal to 21. Okay. Now, the fact that their positive difference is 9 means that when I subtract the smaller one from the larger one, I will get 9. If I did the larger one minus the smaller one minus the larger one, I'd get negative 9. Now we're told x is the larger number. So that means x minus y is equal to 9. Now eventually, this is the kind of system we're going to want to solve by elimination, because in both cases, the two variables are on the same side of the equation. There's no variables kind of hanging out here. Now, we're not going to solve this yet, but we are going to show that something is a solution. So take a look at letter B. Show that x equals 15 and y equals 6 is a solution to this system. Well, this should be a piece of cake. Pause the video now and show that that particular pair of values is a solution to that system of equations. All right, easy enough, right? All we have to do is take those values, plug them into this equation, make sure it's true, plug them into this equation, make sure it's true. And it's particularly easy right now, right? Because all I have to do is do 15 plus 6 equals 21. And of course, 15 plus 6 is 21. Whoops. So that one's true. And then I need to do 15 minus 6 is equal to 9. And of course, 9 equals 9. So you bet, that's a solution. Now, of course, the question is, what is this method that will allow us to take this system and produce these values algebraically? Well, before we do that, we've got to review something else. All right. Now, to solve a system by elimination, we must use what's called the addition property of equality. And like all properties of equality, it's pretty obvious when you think about it. But let's talk about what the addition property of equality is. It basically can be summarized like this. Equals added to equals are equal. But what does that mean? Well, in equation form, if A is equal to B and C is equal to D are both true equations, then A plus C equals B plus D will also be a true equation. And to give you a really, really simplistic example, right? I think we can all agree that 3 equals 3 is a true equation. We can also agree that 5 equals 5 is a true equation. And if I add these two equations together, adding the left to the left and the right to the right, I get 8 equals 8. And surprise, that's also a true equation. And that's all all the principle of like the additive property of equality says. If I've got two true equations and I add them together, it will produce another equation that's true. Okay, now before we use this to do our method of elimination, let's review a very simple idea, which is how to combine like terms. Now I know you've been combining like terms for years now, but it's really going to be important in the method of elimination. So let's take a look at exercise number 2. Simplify each expression below by combining like terms. Okay, so I'd like you to do this. We've done this tons and tons this year, both in solving equations and simplifying expressions and all sorts of things like that. So I'd like you to take each one of these 3 and simplify those expressions by combining like terms. All right, now if it helps, you can always use the commutative property of addition to kind of flip-flop some of the addition. For instance, in exercise number A, I could take the 3y plus 2x and flip-flop it. Not that I really have to, but if it helps you see things, that's never a bad thing. And then of course I've got 4x plus 2x, that's just going to be 6x. I've got 3y plus 7y, and that's going to be 10y. All right, that's simple enough. Easy, easy. Let's take a look at letter B. Whatever. You know, here again, I could flip-flop the 4y and the 3x, and I could get x plus 3x plus 4y. And if you want to think about it as plus negative y, that's okay too. X plus 3x would be 4x, and 4y plus negative y would be 3y. Now, the most important one of all, though, strangely enough, is going to be letter C. Okay? Now, it's important because if I kind of rearrange these and maybe put it all in terms of addition, right? I get 5x plus negative x, which is 4x. And then I get positive 3y plus negative 3y would be, if you will, 0y. But of course, 0y is just 0, so I just get 4x. Now, let's hone in on this one just for a minute, because this is going to be the key one in understanding the method of elimination. You see, 5x plus negative x is 4x. There's still some x's there. But we can think of the y's as being eliminated here because we had what are called additive opposites, or additive inverses. In other words, I had a positive 3y, I had a negative 3y, and when I add a negative and a positive together that are of the same size, that gives me 0. The y variable got eliminated there. All right, very, very important. So now, let's learn the method of elimination. All right, here we go. Exercise number 3. Consider the system shown below. It should look familiar. X plus y equals 21, and x minus y is equal to 9. Letter A. Use the addition property of equality to add these two equations together. Simplify the left-hand side. All right. So let's do this. I'm going to take these two equations and I'm going to rewrite them. X plus y equals 21 and x minus y is equal to 9. Now, the additive property of equality says, all right, I can add the left-hand side of these equations together and I can add the right-hand side of these equations together. So let's kind of do that. If I added the left-hand side of these equations together, I'd have x plus y plus x minus y is equal to 21 plus 9. Okay? Now, when I do that, I'm going to have an x plus x, which is 2x. And then I'm going to have a y plus a negative y. And those y's are going to eliminate each other. So all I'm going to be left with is 2x equals 30. Right? Because a positive y and a negative y are additive opposites, they cancel each other. The y got eliminated. Now let's take a look at letter B. Solve the resulting equation in A for x. And I can do that now, right? Just like substitution got rid of a variable, the method of elimination, just think about the name, elimination, we're going to eliminate one of the variables by adding the equations together. Okay? And of course, this is an easy equation to solve. Here we go. 2x is equal to 30. Let's just divide both sides by 2, and x is equal to 15. Piece of cake. right? And now we want to use that value of x to find the value of y. I can now take x equals 15, substitute it into either one of these equations to come up with the y. Whichever one seems easier to you, that's the one you should use. I think I'll just use the first one, right? That's 15 plus y is equal to 21. If you need to rewrite that left-hand side using the commutative property of addition, you could, right? But either way, I can now subtract 15 and I can get y equals 6. Okay, and in fact, if you look back at exercise number 1, that was that solution that we had checked. X equals 15, y equals 6. All right, this method works beautifully when the variables are on the same side of the equation and when adding the two equations together, one of the two variables gets eliminated. Pretty cool. All right, now, systems are easy to solve using elimination if the two equations contain additive opposites, quantities that sum to 0 when added. So let's look at that situation again in exercise number 4. Consider the system shown below. 2x plus 3y equals 16, and 5x minus 3y equals 19. When added together, which variable will be eliminated and why? All right, well, pause the video now and tell me, will the x be eliminated or will the y be eliminated if I add these two equations together? Well, it's pretty simple. The y will be eliminated, right? Y is eliminated because its coefficients are additive opposites. Never know when red's going to come out. Additive opposites, right? 3 and -3. Okay, so now let's solve the system by eliminating one of the two variables. Let me just rewrite the system here. 2x plus 3y is equal to 16, and 5x minus 3y is equal to 19. Now, I know that in the last problem, when we added the two equations together, we literally wrote down 2x plus 3y plus 5x minus 3y equals, it wasn't with 2x and 3y and stuff like that. Most of the time, people won't do that. They will literally just kind of add like this. And they'll say, well, 2x plus 5x is 7x. And if you'd like, 3y plus -3y is 0. 16 plus 19 is 35. You don't even need to put the plus 0. I just want to emphasize that 3y plus -3y would be 0. And look at how easy that equation is going to be to solve. It's a one-step equation. It's one of the really nice things about the method of elimination is that when you add the two equations together, if one of the two variables cancels, you will be left with a one-step equation, not even a two-step equation. This is literally 7x equals 35. All I have to do to solve this is divide both sides by 7, and I get x equals 5, right? Now, solving for y once we have x in this situation is a little more challenging. It's actually probably more challenging than solving for x, right? I've got to take that 5 and either substitute it into this equation or this one and solve for y. Now, which one's easier? Well, this equation doesn't involve any subtraction, right? So I think I'm going to stick with equation 1 here. So I'm going to put that 5 in for x. All right, and I now need to solve this equation. So I've got 2 times 5, which is 10. 10 plus 3y is equal to 16. If it helps you to reverse the order on that left-hand side, 3y plus 10 equals 16, go ahead and do it. Subtract 10 from both sides. I'll get 3y is equal to 6. Divide both sides by 3. And y, right snuck down there in the lower right-hand corner, is equal to 2. Now, of course, it does not hurt at this point to take the 5 and the 2 and check them in the equation that we didn't use to produce the y. I could even probably do that mentally. Like I'd have 5 times 5, which would be 25. Then I'd have 3 times 2, which would be 6, and 25 minus 6 is in fact 19. Now, right, if you're really kind of comfortable and you're understanding what's going on right now, you might have a very important question, which is, what do you do if there aren't additive opposites, right? I mean, if there's not additive opposites, if there's not a 3 and a negative 3, or a 2 and a negative 2, or a 7 and a negative 7, or whatever, then when you add the two equations together, you're not going to eliminate a variable. And that's really key in this procedure. So let's take a look at that case, right? If additive opposites are not present, then this makes solving using the elimination more challenging. We can often produce these opposites by using the multiplicative property of equality on one of the equations. Now, that's a fancy term, the multiplicative property of equality. But all the multiplicative property of equality says is you can take any equation you want, just a single equation, and multiply both sides of that equation by any number you want, as long as you multiply both sides. You can't do something to one side and not do it to the other side. But the multiplicative property of equality says, hey, you know, if I want to multiply both sides by 2, do it. If I want to multiply both sides by negative 5, do it. I can multiply both sides of an equation by any number I want, and that equation will still be true. So let's take a look at how we can use that in exercise number 5, where there aren't additive opposites. Let's take a look. Consider the system shown below. 2x plus y equals 20, and 3x minus 2y is equal to negative 12. Letter A. What could we multiply both sides of the first equation by in order to produce an opposite pair? What would this new equation become? Show. All right. So again, if I were to just add these right now, let's mentally do this. You know, I'd have 2x plus 3x, and that would be 5x. I'd have y plus negative 2y, and that would be negative 1y. And then I'd have 20 plus negative 12, and that would be positive 8. But either way, I'd have 5x minus y equals 8, and I wouldn't have eliminated one of the variables. So my question is, what could you multiply both sides of this first equation by in order to have something down here that would sort of cancel with that new equation? Think about that a little bit. Pause the video now. Well, although not impossible, it would be a little bit tricky to multiply both sides of this equation and get a negative 3x. It's possible. It is. But it's not pretty. But one thing I could definitely do is multiply both sides of this equation by the number 2, which would give me a 2y, and that would be the opposite of a negative 2y. So I'm going to multiply by 2. And specifically, it's going to look like this. I have to multiply both sides and all of both sides by that 2. So I'm going to multiply the 2x plus y by 2 and the 20 by 2. And my new equation now, after I use the distributive property, is going to be 4x plus 2y is equal to 40. Now, the great thing about the multiplicative property of equality is it's basically saying, look, 4x plus 2y equals 40 is the same as 2x plus 1y equals 20. These two equations, that top one and this one, really are equivalent equations. They just look a little different, okay? Now, let's take a look at letter B. Use the equation in A along with the second equation as a new system, solved by elimination. All right, in other words, I'm now going to just take that first equation and forget about it for a moment, and I'm going to use this equation and this equation as my system. So let me write down that 4x plus 2y equals 20, and that 3x minus 2y is equal to negative 12. Oftentimes people will put a line under the system almost like they're just doing an old-fashioned problem. Let me just take a look, just make sure. Oh, it's not supposed to be a 20 there. It's supposed to be a 40. Awesome. Okay, so notice how I put that line underneath the two equations, right? That's going to be the same equation, and we're just going to add them together now. So what I'd like you to do is pause the video now, add the two equations together, and finish solving this system now that we've got these additive opposites. Once you've solved it, and remember the y's are going to cancel and you'll originally solve for x, Once you get that value of x, then substitute it into one of these two original equations, or actually into this equation or this equation, sorry, because this is our system now, to find the value of y. Pause the video now and go ahead and solve this system by elimination. All right, simple enough. When I add these two together, let me give myself a little bit more room here. When I add these two together, 4x plus 3x is just going to be 7x. And literally a y and a 2y and a negative 2y cancel. Now 40 plus negative 12 is going to be 28. So now I'll just divide both sides by 7, and I'll get x equals 4. Okay. Now remember, at that point, I've got to now take my x equals 4 and substitute it into one of the two equations to solve for y. Which one do I want to substitute it into? Again, is completely up to you. They should give you the same y value. If they don't, then some mistake has happened. But I think I'm going to take it and substitute it into this first equation because there's no subtraction going on. So I will put 4 in there. 2y is equal to 40. 4 times 4 is 16, plus 2y is equal to 40. I'm going to subtract 16 from both sides. Oop. That's going to give me 2y is equal to 24. And now I'm going to divide both sides by 2. And that's going to give me y equals 12. Okay, so x equals 4, y equals 12 is a solution to this system. But take a look at letter C. Show that this solution is a solution to the original system. All right? So my claim is that even though we kind of changed the system by taking this first equation and multiplying both sides by 2 to give us this, it didn't actually change the fact that 4, 12 is a solution to that original system. And let me write those two equations down. 2x plus y is equal to 20. And 3x minus 2y is equal to negative 12. So what I'd like you to do now, in letter C, is take that 4 and that 12 and make sure it makes both of the original equations true. Pause the video now and do that check. All right, let's do it. 2x plus y equals 20. Give myself a little room here. So 2 times 4 plus 12 equals 20. 2 times 4 is 8. Now I have 8 plus 12 equals 20. 8 plus 12 is 20. So you bet it's a solution to the second equation, or the first equation. Now let me do 3 times 4 minus 2 times 12 equals negative 12. I got it barely in there. 3 times 4 is 12. 2 times 12 is 24. Right? 12 minus 24 is negative 12. And that also checks. You see, multiplying both sides of the equation by 2 to produce that additive inverse doesn't change the fact that these two then are a solution to the original system of equations. In fact, applying any property of equality to either one of those two equations won't change whether or not the solutions are solutions to the original system. And that's the beauty of elimination. We can always get additive opposites by multiplying both sides of one or possibly both of the equations by some number to produce those additive opposites. In this course, in Math 8, not Algebra 1 next year, but in Math 8, you're only going to ever have to multiply one of the equations to produce those additive opposites. Algebra 1, maybe you'll have to do both, but for now, it's just going to be one equation. So let's look at one final problem. Exercise number 6. Solve the system of equations below using elimination. Okay, great. So I want you to look at these two equations. One of the two equations, it's going to be relatively easy to multiply both sides by some number to produce additive opposites. Once you've produced that new equation, then form a new system and solve it and see what you get. Pause the video now. All right. Well, one thing I would ask you to look for when solving a system by elimination is whether one of the equations contains a variable where the coefficients equal to 1. Now, if the coefficients equal to 1, the coefficient's the number that multiplies the variable, right? If the coefficients equal to 1, it won't even be written. But take a look at this second equation. We have 1x plus 6y equals 20. I can make that x into anything I want by multiplying both sides by a number. That means that since I've got a negative 3x in the top equation, I could get a positive 3x down here by multiplying both sides of this equation by 3. So that's what I'm going to do. I'm going to actually take this equation and multiply by 3 on both sides. Now I'm not going to do anything to the first equation. That's just going to stay negative 3x plus 5y equals negative 14. On the other hand, the second equation is going to become 3x plus 18y is equal to 60. All right, step back a little bit. It would be hard to eliminate any other variable. It would be hard to eliminate the y. Could you do it? Sure. But what exactly would you multiply this 5y by to make it equal to a negative 6y? Or vice versa, what would you multiply this 6y by to get it to be equal to negative 5y? You could do it, but it would be fractional, and it would just be a fraction nightmare. As is, I multiply this equation, both sides, by 3, and that produces that positive 3x that will eliminate that negative 3x. Let's do it. Right? I now put a little line down here. I add. Negative 3x and positive 3x cancel. 5y plus 18y is 23y. And 60 plus negative 14 is positive 46. Notice now I've got that one-step equation. I divide both sides by 23. 46 divided by 23 is 2. I now want to figure out what my x variable is. I think it's going to be easiest to plug it into this original equation, which I can do. X plus 6 times 2 is equal to 20. X plus 12 is equal to 20. Subtract 12 from both sides, and x is equal to 8. And that's it. You know, we could always then check to make sure it's correct by taking x equals 8, y equals 2, and substituting it into this equation. That's the one equation we didn't use to produce the x value once we knew the y value. And if it then checked in this equation, we would know for certain we got the right answer. All right, let's summarize this lesson. We have now seen 3 methods for solving systems of equations. Graphically, by just graphing the 2 lines, finding their intersection point. Substitution, which works particularly well when one of the 2 equations, or both, has a variable isolated. And then the method of elimination today, when both equations have both variables on the same side, typically the left-hand side, but whatever, you could always flip the equality if you needed to, right? So both variables on the left-hand side, and particularly helpful, when we add the 2 equations together, one of the variables cancels out or gets eliminated because there's additive opposites. Now, sometimes those additive opposites are just automatically there, and boy, that's nice when that happens. Other times we have to use that multiplicative property of equality that basically just says, hey, if I need to, get a negative 3 attached to that x, I could just multiply both sides of this equation by negative 3, right? So you can always use the multiplicative property of equality to get those additive opposites. Now in our next lesson, our final lesson of this unit, we're going to be applying all of these methods. Well, we're going to be applying substitution and elimination to solve a wide variety of applications of systems of equations. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.